important. And my topic today is trying to share some of the best practice that we came out to work and support our European partners, local projects in building and designing their first cells ever in different scales and making homegrown European cells being successful. And my topic's design and process. Um, a little bit about myself before I get started. So I'm Luke. I co-founded Electroder back in 2019, based on a decades of experience in battery cell design and manufacturing. And as Simon mentioned, over the ways we were getting a chance to build a digital tool that improve the process from just purely trial and error. That's how why we built the company in the beginning. And our and it's not just about what not a sales pitch. But I'm also sitting in a steering committee of Global Battery Alliance, of its Battery Passport and Security Critical Mineral Steering Committee. I highly encourage you to look into Global Battery Alliance. It's kind of a very good mission in building sustainable value chains. So before I go to my topic about EU battery manufacturing, I want to make a great statement. For many of you who have known me, I've always been an advocate of Europe need this cell manufacturer, and I think it's going to be possible. It's going to be successful. Although that we're talking about in reality, there are things happening. Some of my topic in the next couple of slides. I want to make it very clear that we need to be confident, we need to be resilient, and we need to be very, very sure that this is gonna work. And I take the opportunity to thank all the ones who have been, putting together an effort in this. So this is the map that showed back in 2021 by BatteryNews.de and about the cell manufacturing project in Europe at that time. And many, 4 years has passed, and let's look back what were the projects and where they are today. And I try to update it. And I hate to use the word of fail, but if the project is started, it's not going anywhere. It's this failed. There are, of course, there are new projects coming up, but there's still a sad thing that seeing what's in front of us, that we had ambition. We have been putting a lot of money, we're putting a lot of effort. Many people have put in a career in it, and it's not coming out the results. And we need to make it work. And a couple of months ago, Nicholas Tangent, CEO of Northern Bank Investments, interviewed Robin Zeng, who is the chairman of CATL, the largest cell manufacturer in the world at this moment. And he asked a question, why that many cell manufacturing projects in Europe has failed. And surprisingly, Robin said something that I had been trying to tell the communities many, many years ago. But of course, Robin has a bigger voice there, right? As he owns 40% of the market in the world. He said, the first thing is because of the wrong design. That's very surprising to many because, and we know that, and I'll explain why the design is so important. And secondly is the wrong process. So the thirdly, of course, also equally important, but putting the third is the wrong equipment. But you can see that design and process are kind of a determining factor in the quality of making cell manufacturing successful in the eyes of the largest cell manufacturer in the world. And cell design is critical because, to very obvious reason is the cell design serves a purpose in different application. And we are facing today, then 12 years ago, we were started in the industry doing commercial designs, is that we're facing many different applications, and each of them is asking for different perspective of cell, and they're different. And so because of that, the design is different, the structure is different, the recipe is different, and the process is different. So not a single cell manufacturing project is the same. So if we take approach of copy and paste from Asia, it's not going to work. And if you're trying to bring and reinvent the wheel, it's also not going to work. So what would be the best approach? So first, I think, the one we need to have is a solid cell design. I've seen and participated and trying to crack in some of the European projects is going there and seeing that it doesn't take quite a lot of efforts between that the project getting money and they place an order to the equipment suppliers. And sometimes even worse is they will like equipment suppliers to do a blues design, to a cell design for them. And you can imagine when the equipment supplier is trying to bidding for €1 billion projects, and you ask, can you do this? Can you do that? Can you do that? And their answer will be yes and yes and yes, right? So, and And then when it got FAT and SAT, you'll face that, okay, that design is not serve purpose. The equipment's not in the boundary. And I found out that's a lot of impractical. There's a lot of things in that. And we need to have a solid design from electrical perspective and as well from cell design perspective, from cell assembly perspective. And then
One
after
minute,
that,
Luke,
yeah,
1 minute.
we need to have a solid process. The process is serve its purpose to building a good product. So again, here is you cannot copy from anywhere because everyone is facing a different conditions in their plant. And some are starting from totally clean sheet, and some are starting from equipment process they're familiar with. And especially in Europe, we need to work on CE, we need to work on the local code and other things. So this is the other part, the process that we develop need to serve the purpose to building the cells eventually. That's because that's eventually we want to build it and produce the cells at high yield rate and high speed. Last but not least, coming to scaling. I think Europe is second to no other places to know how to develop and build cells. What we need to face is we need to make mass produce scalable production works. And that's where the first design and process will lay down a good foundation. If we don't have the good foundation, it's really hard to ramping up and scale. Okay. And last but not least, I'm closing my presentation today that by introducing that I'm working with Professor Lee in Tsinghua University, also a visiting scholar in art application in the past, to work on a book for European and global battery industry. Is we're going to write publish with VD next year on lithium-ion battery cells and focus on design and manufacturing. And I want to close that. Thank you again for together. Let's show resilience, bring know-how, and remain confident to make European battery cell manufacturing possible and working. Thank you.
Thank you, Luke. Thank you very much for this brief insights. I know this talk could go for 2 hours because there's a lot of know-how between every slide that you just showed. To the audience, is there a question up front? I'm looking in the chat right now. 1 second. I don't think so. No, not yet. So let me ask one question because we're a little bit behind time. And that is, how do you see the role of AI in this whole development of new battery technology from the product side and the production side? Do you think it will be a game changer, as many said, or do you also see stumbling stones where you think like good old organic knowledge from the brain and analytical models are still worthwhile and expertise? So can you just give us an estimation there with one quick answer, if that is possible?
Thank you. That's a really good question. In the industry, I'm seeing artificial intelligence currently playing 3 roles in 3 steps in the battery cell production perspective, the development and production. The first is AI has been introducing in developing materials, not only just in battery industry, but in medicine and pharmaceutical. It's coming into developing electrolyte. A lot of them is in high through output calculation as a small one. I think that's where AI is currently being deployed the most. In some of the leading cell manufacturers. The other end of that is AI is being using data learnings and machines learnings in the production side, trying to collect data and analyze things that we couldn't find out today.
Yeah.
What we are doing in the middle is after the material, but before the production, is use that to democratizing battery cell design. Because currently cell design is highly experience and there are lots of know-hows and it's very random. And we have been using artificial intelligence to conduct optimization of cell designs. There are some limitations, but it started showing some really, really good results after large language models started developing. And what I would say, the benefits from our standpoint, looking the most benefits is combining both data-driven as well as physical model. And if the both of that come together, from our perspective, come out the best result.
Okay. Yeah, thank you for the straightforward answer. And I can only reflect that from my discussions along the expedition. This is an answer I get often from other experts as well, having this 2-sided approach. All right, Max.